Hello. Can you guys please confirm whether I'm audible or not? And you can also and please confirm whether my slides are visible or not. Thank you, Nishant. Thank you, ARV. So we'll be starting within 1 minute. Let's wait for others to join and then we can start. Yeah, so I guess we can start. So good evening, one and all. My name is Rituraj Singh Sahawat. I am currently working as a Prime Minister Research Fellow in Department of Earthquake Engineering from IIT Roorkee. This week session is currently being based on the solving the sample questions related to the pile foundations. This course is currently being tutored by Professor Dilip Kumar Bedia, who is Professor in Department of Civil Engineering from IIT Kharagpur. So let me give a brief intro those who are joining this session for the first time. So the objective of these sessions are particularly meant to interact with our learners. We'll be discussing some of the important concepts which are required to solve the assignment problems. We'll also be solving some of the sample questions related to the deep foundation problems. Other than that, if you have any technical query related to this particular part, please feel free to raise your query. We'll have a discussion on that also. And apart from that, if you have any non-technical query related to the research part, or let's say if you look towards the career growth, so we can help you like up to whatever extent it is possible. So this week's sessions is currently being revolve around solving the questions related to the deep foundations. We'll be solving some of the sample questions which particularly deals with the designing and the analysis of the pile foundations and how what are the theories to assess the capacity of the pile foundations, and your today's questions are currently being meant for that part. So let's start with our session today. So this is the question number one. So the first question which is there in front of you, like you need to uh, give the value of the bearing capacity factor for the cohesion NC for which is taken for the piles. So the value of the bearing capacity factor for cohesion NC for piles is generally taken as. Yeah, so the correct answer is B. So usually while assessing the capacity of the pile foundations, the bearing capacity factor corresponding to the cohesion is being taken as 9. So this is the particular part. Then let's move to question number 2. So question number 2 is like a 50 centimeter diameter friction pile is embedded 10 meter into homogeneous consolidated deposit of clay which is having a cohesion of 50 kPa. The safe load for a factor of safety of 3 considering the adhesion factor as 0.8 is. So you need to assess what is the safe load, like the dimension of the pile is given to you, the embedment depth is given to you, the cohesion value is given to you, factor of safety has been given to you, and the adhesion factor is given to you. So this is a cohesive soil. So you need to check the formula corresponding to the calculation of the capacity for the D foundation or for the pile foundation when it is embedded in the place of. Okay, so we have answers. Let's check. So answer is 209.4. So let's solve this. So the case which has been given to you is your pile foundation, which is embedded up to a depth of 10 meter. Here you are having a 50 centimeter diameter. Then the factor of safety which is given to you is 3, and your adhesion factor alpha is 0.8. So usually the pile capacity is given to you as alpha. Yeah, so you need to the safe load for factor of safety. So yeah, so it is given as alpha cu times your surface area as. So this is your pile capacity, pile p ultimate. So alpha is having value of 0.8, your cu value is 10. Then you need to consider the surface area. So surface area is given by 2 pi r, so which is pi into d, and d is how much, is your 50 centimeters, so it's 0.5 meter. Then length is 10 meter. So your p ultimate, which is calculated as, is given as 0.8 into 50 into 3.14 into 0.5 into 10. So it is 628 kilonewton. Then your P safe is given by P ultimate divided by factor of safety. Your P ultimate is 628 kilonewton and your factor of safety is 3. So P safe is given by 209.33 kilonewton. So P safe is your corresponding value of 209.33 kilonewton. So this is your answer. Let's move to our next question. So like here, for designing end bearing piles of a square cross section in clays having average unconfined compressive strength of 100 kPa, the net ultimate bearing capacity is. So one information is it's a end bearing pile, so it's basically resisting the load from the tip resistance. Then the cross section of the pile is a square cross section. You have been given with the unconfined compressive strength, and then accordingly you need to calculate, sorry, the net ultimate bearing capacity. Yeah, you can try. I'll just join within 2 minutes. Yes, sorry for the delay. Let's check the answer. The answer for this question is 450 kPa. So you have been given with the cozy soil. The unconfined compressive strength is 100 kPa. So your undrained shear strength SU will be 100 by 2, which is 50 kPa. The net ultimate bearing capacity, so let me check the dimension. Square cross section with the net ultimate bearing capacity. So the Q is basically your CNC. So the NC value we know, as we have checked from the previous part. The value of bearing capacity for piles is generally taken as 9.0. So your NC value is 9.0 and your C is 50. So your answer will be 450 kp, which is option C. So I think this is straightforward. So let's go to the next question. Then next question, you are having a pile which is of 10-meter length. The diameter is 0.5 meter and it is installed in a stiff clay soil. The CU value is given to you as 100 kPa. The adhesion factor value is given to you as zero point 0.8. The pile load capacity furnished by friction only is. So you need to calculate what is the pile load capacity. Question 4A. 4th. So it has been asked to calculate the capacity corresponding to the shaft friction. So the correct answer is 125.6.6, so option A. So let's check this. So let's say this is your pile when it is subjected to some axial load. So you have been asked, let's say this is the tractions which are available at the surface of pile and the soil. So this is the corresponding shear stresses which have been developed. So we need to calculate what is the capacity provided by this shear stresses. So the total length of the pile which is given to you as 10 meter, the diameter is 0.5 meter, the cohesion value is 100 kPa. So this is unconfined compressed system, alpha value is 0.8. So this is cu value, okay, alpha is 0.8, the pile load capacity. So we know for the capacity corresponding to the shaft friction is given by alpha, then you are having the cohesion value, and then you have been asked to calculate the capacity, so we'll multiply with the area of the shaft. So this is the area of the shaft. uh,
बिजी हो सर बाद में आता हूँ
बताओ।
बिजी हो बाद में आता हूँ
हाँ मतलब मुझे 8 बजे तक अभी क्लास लेना है तो ठीक। So this is alpha CUS. So alpha is your 0.8, cu value is taken as 100, and then as value you can calculate, pi d into L. So alpha is 0.8, cu value is 100, pi value is 3.14, diameter is taken as 0.5, length has been taken as 10 meter. Okay, so it's 0.8 into 100 into 3.14 into 0.5 into 10, so which is your 1256 kilonewton. So the correct answer is A. Then let's move to question number 5. So for the data given in the above question number 4, you need to calculate the ultimate bearing capacity of the pile. So you need to assess the ultimate bearing capacity of the pile for the data given in the question number 4. So ultimate bearing capacity will take the end bearing capacity also into account. So this is your data. So you have already calculated the shaft friction capacity. Now you need to calculate the end bearing capacity, and then you need to evaluate what is the total ultimate bearing capacity of the pipe.
Sir, can you show the data once?
Yeah.
Sir, next slide, sir.
Yeah. Okay, so let's check the answer. So the answer is 1433. So I think you guys have also got the same answer. So we have already value of the shaft friction. So PS value is 1256 kilonewton. So let's say you need to calculate the ultimate. So we need to calculate the P and bearing. So it is given by, first we need to take the bearing capacity factor, then you need to take the capacity of the soil which is given by Cu, and then you need to take the base area of the bed. So Nc we know for the clay soil is given by 9, Cu is given to you as 100, then you are having a base area which is pi by 4 into d square. So it's 9 into 100.784 and your diameter is 0 0.5 meter. So it's 0 0.5 whole square. So your P and bearing capacity is given by 9 into 100 into 0.784 into 0.5 square, which is 176.4 kilometer. So your P ultimate is given by 1256 plus 176.4, which is given by 1432.4 kilonewton. So your, which is close to 1433.3 kilometer. So your answer is B, 1433.3 kilometer. So one good observation you can make it here is like, as you can see the if you compare the amount of load which is taken by the end bearing, uh, capacity of the pile is very less as compared to the shaft friction. So the maximum force is being registered by the, you can see the maximum force is being registered by the frictional, uh, or like the shear stresses which are available between the pile and the soil. So that's why you can see why we need to go for the end bearing piles, or like for the pile foundation, because if you want to resist a very high amount of load, or if you want to transfer the load to a very larger depth, so by increasing the surface area of your foundation you can basically allow the foundation to take more load. So this shaft friction is resisting the load of around 1256 kilonewton, and your and surface area of the pile is taking around 176.4 kilonewton. So if we compare in terms of percentage, so 1256 minus 176.4, so around 85, 176.4 divided by 1256, so 1 minus 1. Yeah, so around 86% of the load which is being transferred to the file foundation is being registered by your shaft frictional resistance. So this is a good observation you can make it here. So P ultimate is 1433.3 kilometer. So let's move to question number 6. So what is the critical depth of the pile? What is the generally the critical depth of the pile is considered as? Yeah, so the correct answer is option C, 10D for the loose soil. So if you see this particular figure, so let's say if you are having a pile foundation, and when you are applying some vertical axial load, so of course you will be having the shear stresses at the interface of the pile and the soil, and then at the base of the pile you are having the end bearing capacity, which is your normal stresses which will be acting at the base of the pile. So combinedly your shear stresses at the shaft friction and the end bearing your normal stresses will provide the capacity. So if you see the increment of the stress along the depth, so when you, let's say this is your ground level, so let's say this is your ground level. So when you further increase the load, so after a certain depth, your after a certain depth your shaft friction will remain constant. So this is the further increment, like as you go along the depth your shaft friction after a certain value, so let's say this is tau s, so this value will get constant after a certain limit. So and there is no further increment in the stress as you go along the depth. So we can utilize only this particular depth for the embedment and resist the vertical load coming over. So this particular value is known as your critical depth, and this critical depth is having a value of around 10 times the diameter of pipe, usually for the loose soil. So this is the thumb rule, or this is the observation which has been made by the researchers during the investigation in the laboratories or as well as in the field testing. So they have found that up to the 10 times of the diameter of the embedment depth, you will be having the increment in the shaft friction capacity. After that you won't be having any further increment in the capacity. So we can cut down or like we can cut our pile up to that particular depth, and this is how the embedment depth is being evaluated, like how is your critical depth is. So this is the answer for question number 6. So let's move to question number 7. So question number 7 to 10 are based on this particular data, so you can note down this data somewhere, and one by one we'll solve this particular question. So you have been given with a 10-meter long pile. The diameter of the pile is 500 mm. Is driven in a uniform deposit of sand. The pi dash value is given to you as 40 degree. The gamma value is given to you as 18 kN per meter cube. The gamma set value is given to you as 20.5. The gamma W value is given to you. The NQ value is given to you. The K value is given to you. The interface frictional angle is given to you. The design is to be carried out ignoring critical depth concept. So you need to ignore the critical depth concept. And so the first question which is there in front of you, so till now whatever questions which you are dealing with is the calculation of the capacity of the pile in the cohesive soil. So this particular section deals with the calculation of the capacity in cohesion-less soil. So yeah, it's a uniform deposit of sand. So this all parameters are given to you, and yeah. So if the water table is a great depth and is not likely to rise, the pile load capacity furnished by the frictional by friction only is. Yeah, so water table is at very larger depth, and you don't observe the further increment of the water table. Then what is the pile load capacity, which is furnished by friction only? Yes. So let's check the answer. It's 1632.4 kilonewton. So I guess both of the two answers which got is option A. So let's see this. So let's say if you are having a certain pile foundation and it has been embedded, let's say up to a depth of uh, this is 10-meter long pile and the diameter is given to you as zero point 0.5 meter. The phi dash value is 40 degree. The gamma value is 18 kilonewton per meter cube. The gamma sat value is 20.5 kilonewton per meter cube. Gamma W value is given to you as 9.81 and Q values has been given to you 1370, sorry, 137, and then K value is 2.0 and your delta is 0.75 of phi dash, which is 0.75 of 40 degrees, your 30 degree. So you need to calculate what is the pile load capacity furnished by friction only. So for calculation of the shaft friction capacity for the cohesionless soil, so first you need to evaluate how your stress diagram looks like. So let's say this is your distribution of the stress will be there. So at the top you are having the 0 kPa, then at the bottom you will be having a value of gamma, so sigma dash v, and then you will multiply it with the k value, so k into sigma dash v. So this is your stress which will be available at the bottom. So your frictional shaft friction which is available to you is the this diagram, so half into 0 k into sigma dash v. So this is your particular stress level available, and then you will multiply it with the interface frictional angle which is available to you, or like we can say also the friction coefficient. So in here it's given by tan delta, so that is your fs value. Now for evaluation of the shaft friction capacity q friction, you need to multiply this particular frictional stress with the area of the like the surface area of the pipe. So this is given by fs into as, so it's half into k into sigma dash v into tan delta. Your surface area is given by pi into d into l. So if you see this, so if you put the value half into 2, sigma dash v value is given to you, yeah, so gamma 18 kilometer per meter cube, yeah, so this will be 18, and your vertical depth is 10 meter, then your tan delta value is tan 30 degree, then this is pi, then your diameter is 0.5 meter, and your embedded length is 10. So if we see this, 1030 into 3.14 into 0.5 into 10. So yeah, the answer which I am getting is around 1631.59 kilonewton, which is close to the option A, 1632.4 kilonewton. So the correct answer is A. So any doubt in this, guys? If not so, then let's move to next part, question number 8. So again, if the water table is at a greater depth and is not likely to rise, you need to calculate the pile load capacity furnished by the soil just below the pile tip. So how much is the capacity available just below the pile tip? So you need to evaluate that. So first for the shaft friction value, now you need to calculate tip friction. So let's check the answer. Answer is D. So this concept is similar to your shallow foundation concept. So your capacity at the base can be evaluated by your Q and Q, like the capacity corresponding to your at a certain level, and then you need to multiply it with the base area. So your Q value is basically your overburden value. So the stress developed at the base of the pile due to the overburden of the soil can be calculated as your sigma dash v, your sigma v into your gamma value, gamma bulk, then your nq value, and then your base area of the pile. So your sigma v value is given by 18 into 10. Your gamma value, gamma bulk value is 18. Okay, it's already there. Your nq value is given by 137.0, and then your a base area of the pile is given by pi by 4 into d square is your 180, 137.0, 0.784 and your diameter value is 0.500 mm, so this is your 0.5 whole square. So your tip resistance value is given by 180 into 137 into 0.784 into 0.5 square. So the value which I am getting it as 4833.6.36. The closest value is D. So are you guys getting the exact value? 4841. Where I made mistake, NQ is 37 pi by 4. Let me take pi by 4, 180 into 137 into shift pi divided by 4 into 0.5 square. Yeah, so this pi by 4 value I have to correct this. So this is pi by 4. So the correct answer is 4841.9 kilometer. So option D is the correct answer. So let's move to question number 9. So yeah, I need to calculate the ultimate pile load capacity. So yeah, this is simple. So whatever value you got from 7 and 8, give the corresponding value for the 9. So let me solve this. Why to waste time? So Q ultimate is your Q bearing capacity and the Q shaft friction. So your Q base value which is there is 4841.9 and your Q shaft value is your 1632.4. So if we check this, is your 6474.37, which is your closer to option B. So the correct answer is option B, question number 9, 6474.3 kilometer. Then let's move to the final part. So till now we were not having the water table effect, but in this particular part, like, we are also introducing the water table, which is present at 5 meter below the ground surface. Then the pile load capacity furnished by the soil just below the pile tip. So yeah, in this particular case you are having a water table which is 5 meter below the ground. Your embedded length is 10 meter. Yeah, so it's at the half depth of your embedded length of the pile. The gamma set value is given to you, the gamma water value is given to you. You need to calculate the pile load capacity, like the end bearing capacity of the pile. So we have some answers. Let's wait for some time.
loppuu kaivasta. Niin käykö näin kaapille? Akka ja akka sulla. Mulla vatten on kaivata. Haluan pitää käydä.
So let's check the answer. Answer is 3858 kilonewton. So let's say if this is your pipe which is embedded in the soil, and then you are having a water table. So this is your 5 meter depth, this is your further 5 meter depth. So you are having the groundwater level which is available at 5 meter depth. So this is your ground. Okay, so you need to calculate how much is your pile load capacity. So your Q tip is basically your frictional base resistance multiplied with the area of the base. So frictional base resistance, so for calculation of the frictional base resistance you need to calculate how much is your effective stress available at this level or at your tip level. So for that you need to calculate your sigma dash vertical. The k value, is it given to you? No, you don't read k value in this. So it's basically q and q, so you need to calculate the overburden. So your nq value is how much? Is 137, and then your q value, for calculation of the q value, so it's basically 5 times of your gamma set, sorry it's a gamma
Gamma dry, sir.
gamma dry, yeah. So gamma dry is given to you,
18.
yeah, it's a gamma bulk we need to take. So 5 into 18 plus then your gamma submerged, so your set value is 20.5 minus your gamma water which is 9.81, and then this particular depth is 5 meter. So your nq value, sorry, your q value is 18 point into 5, 90, 20.5 minus 9.81, answer into 5 is your 53.45. So answer plus 90 is your 143.45 kilonewton
APS, sir. Kilopascal.
meter square, yeah. So nq is your 143.45, then area of the base is your pi by 4 and diameter is 0.5 square. So it's basically answer into 137 into shift pi is 2.5 square, answer divided by 4. So it's basically 3858.79 kilonewton. So yeah, so the closest answer which you are having is option A. So yeah, the correct answer is option A. Any doubt in this, guys, so far? Then let's move to our next set of question. Let me open this. Yeah, so let me share the screen again. So yeah, this is a theoretical question. uh, the function of the pile. So what is the usual function of the pile foundation? Whether is it for the carrying vertical load or to resist the uplift load, to resist horizontal and inclined load, or all of the above? So can you take any numerical which having different layers? So Nishant, are you asking like we need to take some tutorials for so that it should have the stratified layers, is it?
Yes, sir. Different stratified layers. It's layer one, layer two, having
Yeah, I haven't prepared
different
those questions so far, but I guess like in the stratified layers, so till now, whatever we are doing, we just need to modify the calculation of your effective stresses, or like your overburden value will change for the layers. So like it's just the addition of the different capacities available at the each stratified layer. So I'll explain you like qualitatively, like I don't have any particular numerical in that case, but yeah, I'll just explain you the concept, like uh, how to deal with those type of problems. So meanwhile, like you can take question number 11 and then we can.
Sir, can you explain question number 7 once again, like the methodology only?
Okay, just let me check. Question number 7th. Question number 7th. Window. This one.
Yes, sir.
Okay, Nishan. So in this particular question, like you have been asked to calculate the shaft friction value, right? So this shaft friction value is basically, so if you would have read the concept in like our physics, so our 11 12 physics class, so let me add. Okay, seventh question. Insert new slide. So let's say usually like when we have dealt with the questions of the frictional values, so let's say if you are having a horizontal surface, and if you are having a certain block, and let's say you are applying some normal load over it, so you want to calculate how much is the frictional force available here. So at this particular level, so this fs, so this frictional force value is usually given by the coefficient of friction times of your normal force acting on that. So like taking this particular analogy, let's say if you are having a certain pile foundation, you are having a certain pile foundation, and now there is a soil which is around it, surrounded by the pile, right? So now I want to calculate how much is the shaft friction which is acting on that. So for calculation of this shaft friction, first I need to evaluate at this point how much is the normal force acting. So let's say it's the Fn. So in the soil mechanics, if you see this, so let's say if you are having a certain ground, and I want to calculate how much is the confinement acting in this, or also I can say normal force. So whatever vertical stress which is available here, it's a mu times, it's your frictional force, normal stress. So it's basically Fn is your basically k times some coefficient value, multiplied with the vertical stress. So, and for calculation of the shaft friction value, you will just multiply it with the coefficient of friction. So this is your frictional value, sorry, this is your vertical stress value. To convert this into the normal force which is acting on the pile, or the normal stress which is acting on the pile, you will multiply it with some k value, and this value when multiplied with the coefficient of friction mu will give you the shaft friction which is acting on this. So this total value, this is Fm, and this total value is your Fs. So this is your Fs. So nu in terms of soil mechanics is given by tan delta. So similarly, for calculation of the shaft friction value, like throughout this step, you will calculate how much is your effective stress, or like how your stress diagram looks like. So if you see the stress diagram, it looks like this, and to convert into the normal stress which is acting, we will multiply it with the k times sigma dash v, and since this is a triangular distribution, so what value we need to take for calculating the normal stress? So we will particularly take the average of this stress diagram, so that's why we have taken half times of k into sigma dash v. So this is your Fs value, right? And now this tan delta is your mu value, and then you have multiplied with the area of the pile, which is basically giving you the capacity corresponding to your shaft friction. So this is how you deal with this particular parts. Nishant, am I clear, or if you have any other doubt?
Yes, sir. Clear, sir.
Okay, okay, Nishant.
Thank you, sir.
No worries. So let's say if you are having the stratified layers. So let's say if you are having a layer 1 available here. This is layer 1. Then this is your layer 2. So the only challenge which is available here, like you need to see how to calculate the stress diagram. So let's say if your stress diagram at this particular layers look like this, then after a certain point you will be having a certain stress diagram values. So that's how you need to deal with. So layer 3. So you need to take the average of the stress diagram in this case, or you can also take the area of this stress diagram.
Sir.
Okay, so can you move to that question? Do we have answer question number 11D? Let me reshare the screen again. Okay, documents. Yeah, so I'll just reshare the screen again. So the correct answer for question number 11 is all of the above. So the function of pile foundation, if you see, is to carry the vertical load, which is P axial. Then let's say if you are having a certain structures, so let's say towers, or if you are having the high rise building which are subjected to the high wind forces, or if you are having offshore structures which are subjected to high environmental forces, then in this case your piles are also subjected to the uplift forces. So this is your P uplift. Then in the similar cases like the wind forces, or in your offshore cases, your pile is also subjected to the horizontal load, as well as if you are having the multi-hazard events when where you are having the combined loadings, then the total resultant force can also be your inclined load, P incline. So in this particular case, in all those particular case, you basically use the pile foundation. So the correct answer is option D, all of them. Then let's move to question number 12. Uh, the pile which transfers majority amount of load to the pile tips is called. So yeah, it's a theoretical question. Just see this. Yeah, so the correct answer is option B, and bearing pile. So the pile which transfers majority amount of load to the pile tips is known as the end bearing pile. Then let's move to question number 13. Okay, I think we have already taken this. Yeah. The homogeneous consolidated deposit with a safe load with a factor of safety and I guess we also have dealt with such type of question. Yeah, it's also over. This also I guess we have taken. Yeah, so yeah, 16 and 17 are somewhat new. So no, so this is also a similar case, 16 or 17. Yeah, so we have dealt with such type of questions. Do we have any other questions? Yeah, we don't have any. So guys, if you have any doubt, please let me know in any of the part today. So we have done with the question today, uh, but still have some time, so I can show you a little demonstration like how do we model pile foundation using numerical softwares. So let me take one of the example. Meanwhile, if you guys have any doubt, please ask. Other than the questions or like in the questions we have done today, if you don't have any, then I can give you a little demonstration like how we usually assess the capacity of the pile foundations using the finite element softwares. Yeah, so I'll just be back within 1 minute. Okay, so I'll just give you. So my research topic basically revolves around assessing the lateral load capacity of monopile foundations. So monopile foundations are the type of the deep foundations which we basically use to uh, plan the foundation for offshore wind turbines. So recently, if you see the most of the nations they are moving towards the renewable energy sector, and considering the different sources of renewable energy, offshore wind energy is also one of the case where they are basically trying to harness the energy from the wind turbines which are specifically located in the oceans. So if you see can you guys guess what is the typical dimension of wind turbine towers which are located, how much is the height usually if we go for the wind turbines which are located in oceans, any wild guess you can guys can make. So what are the typical dimensions, what's the height of the offshore wind turbine? Guys, are you there with me?
Around 30 or 40 meters, sir.
Yeah, so the tower height basically goes up to, let's say, the 240, 350. It goes up to 170 to 180 meters. So you can imagine the total height. So for supporting those type of structures, we usually go for the pile foundation. Just give me 1 second. Models. Global scouting. I'm just opening the softwares. So yeah, I'll just show you. So so this is how your typical wind turbine looks like. So if you see these particular towers, so this tower, let's say the monopile foundation which is embedded in the depth in the seabed is around 0 to 30 meter. So 30-meter, you guys can imagine it's a 10-story building, and this particular height above the ocean is usually goes up to uh, 220 or 240 meters. So 240 meters, if we can see the 240 divided by 3, if we see, so it's basically 80-story building, you guys can imagine. So this is how the wind turbine height goes. So usually for supporting this type of wind turbines, and if you see in the oceans, they are subjected to high environmental forces. It usually the wind forces or your wave forces, as well as your seismic forces. Then you are having the frequency of the turbine also, which is contributing to the dynamic forces on your foundation. So all these forces, to resist all these forces, the most popular foundation which is used for the wind turbine is your pile foundation, or is your or we usually say it's the monopile foundation. So this is how the typically design works like. So usually in the industry, like people go with the Winkler beam approach, where the instead of modeling with a continuum, they basically use the springs. So currently the whole research revolves around like how do you particularly assess this spring coefficients. So just wanted to give you the demonstration. Yeah. So this is how the monopile foundations is. So you can see like the height of a particular person, and at the same time you can see the dimension of the pile foundation. So the pile foundation is having a great application in terms of the offshore wind industry, and this is the most popular foundation. It's not like this is the most efficient foundation, but if you see the if we see as per the logistic purpose, or if we see as per the installation purpose, so usually dealing in the offshore sector demands is a huge capital intensive projects. So you usually go with the options which is more economical as well as the feasible, and that's why if you see this pile foundation, though they are in greater dimensions, but if you see as compared to the other alternatives, this foundation contributes, or this foundation is one of the most efficient alternative for resisting, which is acting as a foundation for the wind turbines. So yeah, these are the different methods. Now there have been recent studies. So we are basically trying to model these foundations and assessing the capacity in different sectors. So I'll show you one of my plexus model which I have developed. Uh, so yeah, this is how the my typical model looks like. So in this particular case, let's say first we have tried to model a soil. So this is the soil. So actually we have just modeled the half of the geometry. Why so? Because you can see like the we are just modeling the lateral load, and to take the advantage of, or to exploit the symmetry of your system, we have just tried to model the half of the geometry. So this is your soil system available, and then this is the structure, and this is your pile foundation. Also you can see we have tried to introduce the interface elements. So this brown color elements is basically the interface elements which has been introduced between your pile foundation as well as the soil. So whatever shear stresses which we were calculating in our today's sample questions, so okay, in theory we know how to do that, but while come to the continuum modeling approach or in the modeling approach, uh, the software needs to know like how the behavior is like when the pile is introduced to the soil. So this particular relative movement between your pile foundation and the soil, the development of the stresses due to that particular mechanism can be taken into account with the interface elements. So this is your brown elements is basically your interface elements. Then again you need to
Software
discretize.
name. Software name. What is the name of this software you are
This is
using?
Plexus 3D. Can we move further? Yeah, so if we see like we have basically discretized the whole soil, and this is how your discretization basically looks like. So this is your pile foundation, then this is your soil domain, and this is your interface element which has been introduced between your pile. Also we have introduced some of the dummy beams. So these are the beams which has been introduced at the pile foundation. These dummy beams have been introduced so that like these dummy beams are having very low stiffness. So when you try to assess the behavior in the pile foundation, so these dummy beams can take account of this particular part. And then you are having your stage construction. So in our Plaxis modeling we'll try to introduce the thing one by one. So this is your initial phase where first we have introduced the soil, then we have introduced the pile foundation. So this is how in the site also it works. So first you will introduce the soil, then you will introduce your pile foundation, then you try to subject your pile foundation to certain lateral loads. So this lateral load, right now if we see the output of this particular model which we have developed, so if we see the output of this model, yeah, so you guys can see like this deformation, right? So if I see the deformation ux, yeah, so whatever stresses or the displacement, so this finite element softwares can directly give you that. So let's say we were calculating how shear stress or the tip resistance basically look like. So if I see the sigma, this is x z, yeah, yeah, so these are the value of the shear stresses which is acting along the pile foundation. So at this interface, so whatever shear stresses value which you are calculating with the given Tarjagi's formulas or let's say Mayer formulas, these capacities can be assessed like with much higher accuracy using the finite element softwares. Again, it depends like how accurately you have developed your model. So if you don't have the precise background of the modeling, so it's better to go with the theoretical, or let's say the empirical relations which have been given, which we were using in our tutorials, or let's say in our sessions today. So this is the tau x sigma zx value, which is basically giving you the shear stresses available at the interface of the pile foundation and the soil. Then you are also having the stresses, Cartesian effective stresses, your sigma dash z. So here you are having the normal stresses which is acting at the base of the pile. So whatever tip bearing capacity which we are calculating, or whatever the tip bearing stresses which we are calculating in this particular software, we can evaluate it using the sigma dash z. So basically there we are assuming like your whole soil is uh, the behavior of the pile foundation is uniform throughout the base of the pile, but this is not really the case. When your pile is subjected to certain amount of load, then you can see like there is some distribution of the stresses at the base of the pile which is not uniform. So yeah, this is the like way, like we basically go for the analysis of the pile foundation using like one of the case we have also seen for the shallow foundation in one of our previous tutorial, and this is the session I want to show like how do we assess the capacity of the pile foundation using the finite element model. So yeah, this was, I know it's very difficult to understand like in such a small demonstration, but like I just wanted to give you like an intuition like how the things work. I think some of you have already done on such type of platforms, and those who are new to that, I just want to highlight for them. So if you guys have any comment on, or like if you have any query, whatever we have discussed in the finite element part, please feel free to discuss. Yeah, if not so, then I think we can wind up our session today. Thank you for joining. Those who are watching this session at a later stage, to our YouTube channel, so you can post your queries or any technical doubt. You can post it in the comment section of the YouTube video. We can address your particular query through that particular channel, and the people who have joined till now, have joined today, like you can ask your query, as we can meet on next Tuesday at 6 at same time at 6 p.m. Thank you Arvi, thank you Vijay, thank you Nishant for joining. Thank you so much. So yeah, we can call it a day. I'm ending the meeting now. Thank you so much. कितना बोलना पड़ता है